Section 6.5 is on the properties of logarithms. So we're going to recall the definition and then do some explorations to develop these properties. So recall the definition: y equals the log to the base a of x if and only if, my little abbreviation for if and only if, a to the y is equal to x. And remember, these y values, this y and this y, these are our exponents in both forms. That's the exponent, and remember the a in both forms is the base. Okay, we have to know both of these forms and be able to fluidly move back and forth. So let's look at exploration number 1. Calculate the following. How can we evaluate log base 5 of 1? So in other words, 5 to what power gives us 1? 5 to what power will give us 1? 0, right? So 5 to the 0 power equals 1. 0 is our exponent. Well, what about 2 to what power equals 1? 2 to what power equals 1? What power would we put there? Well, that's also 0, isn't it? Well, how about this one? What's the base here? 10. Yes. To what power equals 1? Ah, we're starting to see a pattern, aren't we? And the base here, of course, is, when it's natural log of 1, what do you think the natural log of 1 is equal to? I think it equals 0 because I've seen it over and over here. In other words, e to the 0 is 1 because e is a non-zero number, right? A non-zero real number. Okay, so we've seen a pattern here. Every time we've taken the log of 1, it didn't matter what the base was at all. The log of any base of 1 gave us 0. Well, look at the patterns here. We're looking for the log base 5 of 5. What's that equal to? So 5 to what power gives me 5? Well, 1, of course. 1. And 2 to what power gives me 2? Again, 1. All right. Log base 10 of 10? I'm thinking that's 1. And the natural log of e, so e to what power gives me e? The first power. So the log of 10 is 1. This you can calculate on your calculator. Just try it. Take the log of 10, take the natural log of e, and you should get 1. Okay. All right, so let's summarize. This says the log of any base to any base of 1 is equal to, so we saw that here in A, B, C, and D. It didn't matter the base, it always equaled 0. And when the base matched the argument in E through H, the result was always 1. So these are properties, our first 2 properties of logs. All right, in exploration 2, we're going to use some examples to understand the next properties. We have 2, and the power is the log base 2 of pi equals m. So let's just change it to an exponential, change this exponential to a log and see what we get. So the exponent is my y is log base 2 of pi equals, and then I write log base a is 2 of the argument. So I have log base 2 of pi equals log base 2 of m. M is the variable. Pi, of course, is an irrational number. So that just tells me that m must be equal to pi for this to be true. Okay, and let's try here changing this one. So we have a log. Let's change it to an exponential. The base is 3. The exponent is m. And the argument is 3 to the negative 5. So I get m equals negative 5. So let's see what properties we've summarized here. From this one, that looks like our number 3, property 3. We have a to the log base a, 2 to the log base 2 of pi, of m. Well, when it was 2 to the log base 2 of pi, the result was pi. So a to the log base a of m, that result must be m, whatever m is. And then here we have the log base 3 of 3 to the negative 5. This is reminiscent of the one here where the base and the argument are equal, but it's the base and the argument raised to a particular power, but look at the result. It was that particular power. Well, that's what we found here too, because the particular power on all of these was 1. Instead of negative 5, we had a 1 there, 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 and the result was 1. Now it's negative 5. So that was negative 5. So whatever that power is, this is what that evaluates to. The log to the base a of a to some power is just whatever that power is. And we have these restrictions that m and a are positive real numbers, a is not 1, and r can be any real number.